Okay, this is another example for area and volume. So we're going to consider the region bounded by x equals y squared plus 5 and y equals x minus 7. So first we'll graph those. X equals y squared plus 5 is a parabola that opens to the right and shifted to the right 5 units. So it looks something like this, where that x-intercept is at 5. Y equals x minus 7 is a slanted line with slope 1 and y-intercept negative 7. That means we're going to get some sort of graph that looks about like that. It would end up intersecting that y-axis at negative 7. We're going to go ahead and find the intersection points. To do that, we need to have the two equations solved for the same thing. So I've got x equals y squared plus 5. That is a little complicated to solve for y because of the plus or minus once you solve for the square root, or once you do the square root, so we're going to avoid that. We're going to take the y equals x minus 7 and solve that for x. That gets me x equals y plus 7. So I'm going to set y squared plus 5 equal to y plus 7. Get 0 on one side, so y squared minus y minus 2 equals 0. That gets me y minus 2 times y plus 1 equals 0. So y is 2 or negative 1. This is the point where y is positive 2. If I plug that into either equation, I get that x is positive 9. This point is where y is negative 1. If I plug that in, I get that x is 6. We've now got the region drawn. We've got the intersection points. We choose now, and we've got the boundary. We're going to choose a horizontal rectangle here, what we describe informally as horizontal. The base of the rectangle is then dy. If we had chosen one where it's dx, we would have to split this into two regions and use two separate representative rectangles. We'd like to avoid that. All right, so we're going to go through revolving the region about a few different lines. So we'll start first with x equals 10. So if I start with x equals 10, that's a vertical line to the right of the region. So we're going to draw that here. If we think of the rectangle as being horizontal, the line is then vertical. We think of the rectangle as being perpendicular to the line. That means we're going to use the disk washer method. So we're going to have a large R and a small r. These are going to be functions of y, not x, because we chose dy. So we're going to have big R of y, small r of y. Big R is the distance from the line we're revolving around to the farther away end of the rectangle. That is a horizontal distance, so you take the right x minus the left x. We're going to take the right x as 10. The left x, I didn't label this, but it was x equals y squared plus 5. So we subtract y squared plus 5. And after simplifying, we get negative y squared plus 5 again. It's important that because we're using everything in terms of y here, that I want this equation solved for x. So one thing to note is that when it's a dx problem, you want to deal with y equals. So if it's dx, solve for y. If it's dy, we should solve for x. So we're going to label this as x equals y plus 7, and we're going to use that in the next part of the problem. So small r is the distance from the closer end of the rectangle, which is right here, to the line we're revolving around, which is right over here. So you take the right x, 10, minus the left x. But the left x is y plus 7 because it's the x value on the slanted line. That gets us negative y plus 3 after you distribute the negative. Volume then is pi times the integral big R squared minus little r squared. So negative y squared plus 5 squared minus negative y plus 3 squared times the thickness dy. We're going to add this for all of the y's within the region. If you look at the region, the y at the bottom is negative 1. The y at the very top of the region is positive 2. Okay, so we'll put two more up that I'd like you to pause the video and try. take a couple minutes to do problem 2, which is we'll do x equals 4. No, let's do x equals 2. And then problem 3 will be the y-axis. Pause the video, try those, and then check them with me in just a second. Okay, so x equals 2, we'll do this one in red. It's to the left of the region. Again, we think of it as being perpendicular to the rectangle, so we're going to use the disk washer method. R of y is then right x minus left x. The x on the right is y plus 7. The x on the left is 2, so we get y plus 5. Small r is the distance from the closer end of the rectangle to the line. The closer end is the left end of the rectangle. So we take the right x, that's y squared plus 5, minus the left x, that's 2. So we get y squared plus 3. This is disk washer method, so volume is pi times big R squared minus little r squared. That gets us pi times y plus 5 squared minus y squared plus 3 squared dy, and we're going to add them for all the y's in the region, which go from -1 to +2. The y-axis works just like the problem 2. It's a vertical line to the left of the region. Big R is the right x minus the left x on this distance. So the x on the farther end of the rectangle to the x on the y-axis. The right x then is y plus 7. The left x is 0. Small r is the distance from the closer end of the rectangle to the line, to the y-axis line. So you take the right x, which is y squared plus 5, minus the left x, which is 0. That gets us y squared plus 5. Volume then is pi times the integral y plus 7 squared minus y squared plus 5 squared times the base dy, or the thickness dy, from -1 to +2. Let's do 2 more volume problems. Number 4 will be y equals -7, and number 5 will be y equals +4. Pause the video, try those problems, and then check them with me in just a couple minutes. Okay, so I'm going to rewrite this so we can see it up here. But number 4 is y equals -7. That is now a horizontal line, which we think of as being parallel to the rectangle. So we look at that, and we've got y equals -7, we'll say is down here. Because it's parallel, we're going to use the shell method. The shell method is 2 pi RH. And so if I use 2 pi RH, we get a radius function and a height function. The radius function is the distance from the rectangle to the line. That's the distance from up here to down here. The top y minus the bottom y then is y minus -7, which is y plus 7. H is the height of the rectangle. Because the rectangle is sideways like this, dy is considered the base of the rectangle. So the height of the rectangle we're going to think of as being this horizontal distance. So you take the right x, which is y plus 7, minus the left x, which is y squared plus 5. So we get -y squared plus y plus 2. Volume then is 2 pi RH. So we get 2 pi times the integral y plus 7 times -y squared plus y plus 2 times dy from -1 to +2. All right, let's do y equals 4, but we'll do it toward the top of the screen. So y equals 4 we'll say up here, And let's do this one in blue to keep it straight. And so y equals 4 is a horizontal line above the region. Because we think of this as being parallel, we're again going to do the shell method. So we get 2 pi rh. R is the distance from the line we're revolving around to the rectangle. That's 4 minus y because we take the top y minus the bottom y. The height is the same height as it was before, and after simplifying we get negative y squared plus y plus 2. That means the volume is 2 pi times r times h. So we get 4y times negative y squared plus y plus 2 dy inside the integral. And we go from negative 1 to 2 because we want to add all of the rectangles for all of the y values in the region. Last thing I'd like us to do is the area. Take just a second and pause the video and try that on your own. Area is just height times dy or height times dx. The height is the right x minus the left x within the rectangle, so it's the same as the height on the shell method. Area then is the integral of just that, negative y squared plus y plus 2 times the base, but the base is dy, and we go from negative 1 to 2. All right, that's it for this example. Thanks for watching.